Did you know that right now you are surrounded by something invisible? Something that outweighs all ordinary matter 5 to 1. It shaped every galaxy and every living thing, yet it represents a gaping hole in our understanding of physical reality. The universe we think we know, atoms, stars, and light, is only 5% of what exists, and we have absolutely no idea what the rest is. For decades, we've hunted it in silent labs. Now NASA's latest discoveries are bringing us closer than ever. The James Webb Space Telescope is finally revealing the dark matter architecture of our cosmos in unprecedented, exquisite detail. Buried within these images are clues pointing us toward the substance that built the universe we live in. This is the story of dark matter, a mystery that began in the 1930s and is only now being solved. Stay with me. I read every comment. Type SMART below if you're ready for the full deep dive. Don't forget to like and subscribe. To solve the mystery of dark matter, we must go back to 1933, to a man who didn't care what others thought, Fritz Zwicky. While studying the Coma cluster, Zwicky found galaxies moving at impossible speeds, 400 times faster than the visible matter could explain. He called it dunkle materie, dark matter, but for decades his radical vision was ignored by a skeptical scientific world, until the 1970s when astronomer Vera Rubin looked at the spiral arms of distant galaxies and found the same stubborn paradox. Stars at the edges were moving just as fast as those at the center. By every known law of physics, they should have flown apart. The only explanation? A massive, invisible halo of dark matter cradling every galaxy in the universe, providing the gravity we couldn't see. Today, dark matter is an established fact of the cosmos. We know it's there. The only question left is, what exactly is it? Stay with me for part 3 as we go deep underground to find the particle itself. Don't forget to like and subscribe. To find dark matter, we must understand its rules. It has 4 unique properties that don't match anything else in physics. First, it is massive, outweighing us 5 to 1. Second, it is dark, completely invisible to every form of light we have ever detected. Third, it is cold, moving slowly enough to build galaxies. And fourth, it passes through your body by the billions without leaving a trace. These rules pointed toward a single candidate, weakly interacting massive particles, or WIMPs, the absolute favorite for over 30 years. Scientists call it the WIMP miracle. Independent theories in particle physics predicted the exact particle needed to explain the entire cosmos. This stems from supersymmetry, the idea that every particle we know has a heavier, invisible partner waiting to be found. We had the perfect theory and the perfect particle. All we needed to do was catch it, and that's where the real challenge began. Type WIMP below if you're ready for the finale. Stay with me as we go deep underground. Like and subscribe for the conclusion. The great dark matter hunt began in the 80s. Since then, we have pursued 3 parallel paths to find the invisible. First, direct detection. We built massive tanks of liquid xenon deep underground, shielded by kilometers of rock, waiting for a single collision. And for decades, these detectors have heard nothing. Not a single confirmed signal, even as our sensitivity reached impossible levels. Second, indirect detection. NASA's Fermi telescope searched for dark matter annihilating in the centers of galaxies, producing detectable radiation. We found a tantalizing glow at our galaxy's center, but it may just be ordinary pulsars, hiding the truth behind a veil of complexity. Third, collider production. At CERN, we smashed protons at nearly the speed of light, hoping to create dark matter in the debris. We discovered the Higgs boson, but dark matter remains absent. The simplest versions of our theories are failing. The universe is more stubborn than we imagined. Type stubborn below if you're ready for the finale. What if we're looking for the wrong thing? Stay with me for the conclusion. Like and subscribe. The era of WIMP dominance is over. Our silence hasn't shaken our conviction that dark matter exists, but it has changed everything about what it might be. Enter the Axion, extraordinarily light, yet so abundant they could account for everything. We're now hunting them with powerful superconducting magnets. From ghostly sterile neutrinos to fuzzy quantum waves and even primordial black holes, the list of candidates is growing into a bold new frontier. But what if dark matter doesn't exist at all? Radical theories like modified Newtonian dynamics suggest our very understanding of gravity is wrong. While MOND explains single galaxies beautifully, it struggles with the vast cosmic web. For most, the dark matter hypothesis remains the only answer. We are living in the greatest era of discovery. Whether it's a new particle or a new law of nature, the full story of our universe is finally being written. Thank you for joining me on this journey. The mystery continues, and the answer is out there, waiting in the dark. If you enjoyed this series, share it with a friend. I read every single comment. See you in the next exploration. Don't forget to subscribe. While the debate about dark matter's nature continues, NASA's latest observations have provided a revelation no theoretical model anticipated. Using gravitational lensing, the James Webb Space Telescope is mapping the dark matter distribution in galaxy clusters with extraordinary detail. The smoking gun is the bullet cluster. 2 clusters crashed, and while the hot gas slowed down, the dark matter passed right through like a ghost. This spatial separation is direct proof. Dark matter is a real physical substance. This observation effectively rules out most alternative theories of gravity. Hints of self-interaction are even emerging. Particles might be scattering off each other, solving long-standing puzzles like the core cusp problem. We are no longer just guessing. We are mapping the invisible scaffolding of our universe. The story of dark matter is no longer a mystery of if, but what. The answer is waiting in the dark, and for the first time, we can finally see its shape. Thank you for finishing this journey with me. If you loved this series, let me know in the comments. I read them all. See you in the next exploration. Don't forget to subscribe. Beyond individual clusters, we are mapping dark matter on the largest scale possible using weak lensing, the tiny distortions of billions of galaxies. This technique, called cosmic shear, reveals how dark matter is clumped across the observable universe, encoding the very laws of our cosmological model. Upcoming missions like Euclid and the Roman Space Telescope will extend our reach, mapping the dark architecture with unprecedented precision. But the most revolutionary clues are coming from the smallest scale, the ultra-faint satellite galaxies that surround our own Milky Way. These tiny giants are held together almost entirely by dark matter. They are pure laboratories where the invisible force dictates every move. They pose stubborn puzzles. Why do we see fewer satellites than our theories predict? These gaps are driving the next decade of discovery. From the largest cosmic maps to the smallest stars, the story of dark matter is reaching its peak. The final piece of the puzzle is within our grasp. Type dwarf below if you want more of these tiny giant deep dives. Stay with me as we continue to map the invisible. Don't forget to subscribe. The search for dark matter has reached a peak. Today, our observations and our most powerful simulations are finally converging. Webb is revealing how early ionization quenched star formation in the smallest dark matter halos, providing a new census of the invisible universe. Modern supercomputers now simulate entire universes. They prove that cold dark matter provides the essential scaffolding for every galaxy we see. But the story is complex. Feedback from stars and black holes reshapes the dark matter, creating a beautiful interplay between the visible and the invisible. A new window has opened: gravitational waves. LIGO and Virgo are hunting for mergers of primordial black holes, relics of the Big Bang itself. With upcoming missions like LISA and the Einstein telescope, we are about to hear the universe in ways we never thought possible. The answer is no longer a mystery of if, but a question of time. Thank you for finishing this extraordinary journey with me. If you followed us from part 1, let me know your favorite theory below. I read every comment. See you in the next exploration. We are at a genuine inflection point. The old certainties of dark matter have been shaken, forcing us to broaden our horizons and explore the unknown. From Hubble to Webb, NASA's space observatories have been at the forefront, revealing that dark matter is not just scaffolding, but a dynamic, structured reality. We now know that our familiar world, stars, planets, and even our own bodies, represents only 5% of everything that actually exists. We are, in a sense, a minor footnote in the universe's mass budget, but this is not cause for despair. It is a cause for profound wonder. We are finally learning to read the universe in the dark, tracing the invisible architecture that shaped every star and galaxy we see. The answer is out there, and when we finally understand it, we will fundamentally transform our understanding of what it means to exist. The day of revelation is coming. Thank you for joining me on this extraordinary journey into the heart of the unknown. If you followed us from the beginning, thank you. Stay curious. See you in the next exploration. Don't forget to subscribe.